Part 2, Reducing Fractions. A fraction has a top, called the numerator, and it has a bottom, called the denominator. And reducing means that you have the ability to find a number that will divide top and bottom by the same number so that it becomes something a bit smaller. That's why it's called reducing. In this case, both top and bottom of this fraction are divisible by 2, leaving us with the answer of 3/4. 3/4 is the reduced form of 6/8. Now, I've hardly mentioned the concept of fractions before we get into a debate on how we should write them. As you can see, I've taken the liberty of writing 5/9 times 18/25 times 7/8, but the top form is the way a lot of people want to write it. The bottom form is the correct way of writing it. Can you see that when you multiply these together, and we'll get into this more in further lessons, 5 will go into 25 5 times. But when you're looking at the initial problem written with those cute little slanted lines, you can't tell which one is top and which one is bottom, and it gets very confusing. So make sure that all of your fraction bars are horizontal. Now, what we're going to do is, when we're given a fraction like 50 over 100, we're going to mentally ask ourselves what number will go into both of these evenly. Well, with the number 50 and 100, lots of things will go into this evenly. And can you see that we'll be dividing top and bottom by 2, and we can get 25 over 50. We can divide top and bottom by 5, and we would then get 10 over 20. We could divide top and bottom by 10 and get 5 over 10. Or we could divide top and bottom by 50, and that would be our simplest form of 1/2. Do you see all of these answers are the same, but what we want to do is make sure that we write it in the simplest term. Now, keep in mind, the reason why we're allowed to divide top and bottom by 2 is essentially we're dividing this fraction by 1. It's like if I had 5 cookies and I wanted to divide them among one person, me. I don't like sharing cookies. So if we divide 5 cookies by 1, each person, me, gets 5 cookies. Now, this is a fancy way of dividing by 1. 2 divided by 2 is 1, and any number divided by 1 will equal itself. So just as 5 divided by 1 doesn't change, it becomes 5. 6/8 divided by 1 doesn't change either. The value is still the same, but the number is reduced. Let's look at another example. If we were given 18 over 24, we could ask ourselves what number will go into both top and bottom evenly. And this is a fairly easy one. Can you see that 6 is pretty easy to see that 18 is made up of a 6 and 24 is as well. So 18 divided by 6 is 3, and 24 divided by 6 is 4. Now, knowing that is helpful. However, sometimes we can be given nasty problems. And what if we had 48 divided by 336? Now, there's a lot of ways to do this. One of them is to chip away at the numbers, and this could take a long time, but it still gets us to the correct answer. We notice that both of these are even numbers, so we can divide top and bottom by 2, and by doing so we get 24 divided by 168. If you want to do that off to the side, you can verify it. We can divide it by 2 again, and we could get as our answer 12 divided by 84, and by 2 again, and we get 6 divided by 42, and by 2 again. As you can see, we're just chipping away at it. That's called the chipping away method. So once we get this, we're left with 321s, and notice that both top and bottom are divisible by 3, and our final answer is 1/7. Now, is there an easier way to do this? You betcha. This is the forever way, and eventually you're going to make some kind of a dumb mistake along the line. So what I'm going to do is go back to factoring. And we know that 48 is, well, I know it ends in a 2. It ends in an even number, but 48 is divisible by 4, and I get 4 times 12. 4 is 2 times 2. 12 is 4 times 3, and this 4 is 2 times 2. Now, in a similar way, I could look at the number 336, and I know that it's an even number, so let me pull the 2 out here. 2 times 168, I'm looking up above and getting that, and 168 is 2 times 84, and 84, let's see if I get a little bit more room, 84 is 4 times 21, 4 is 2 times 2, and 21 is 3 times 7. Now, the number 48 has 4 2's and a 3. So if I gave you 48 over 336, the number 48 has 4 2's and a 3. That's what this factors into. And the number 336 gets us 1, 2, 3, 4 2's as well. 1, 2, 3, 4 2's as well. And a 3 and a 7. You notice that that's what's left over. Now, once we have it in factored form, we can simply cancel. 2 divided by 2 is 1. 2 divided by 2 is 1. 2 divided by 2 is 1. And again, we have 1. And now 3 divided by 3 is 1. What's left on the top are 1's, and what's left in the bottom is a 7. So as you can see, here are 2 distinct methods of being able to reduce the same fraction, but as long as we've used the proper reasoning, we will always get the same answer in the world of math. Before we go on to the next lesson, we have to look at the concept of what reducing is all about. So if I gave you the number, say, 10/15, the object of reducing is to find the largest number that will divide into both top and bottom evenly, and this will reduce this to its lowest terms. However, what if the 10 and the 15 were reduced in this case? What if we had the 15 on the top and the 10 on the bottom? The concept of reducing is still the ability to divide top and bottom by the biggest number we can, in this case 5, and that will give us 3 divided by 2. Both of these are reduced to its lowest terms. Now, there's 2 things that are brought up here. One is, what is reducing? Well, it is the ability to find a value equal to the original value in a more simpler form. In math, we have 2 responsibilities. One is to get the right answer, and the second, and as important, is to be able to communicate, I'm just going to abbreviate that, is to communicate that answer in the easiest possible form. So if you had a choice between saying 10/15 or saying 2/3, every time I would pick 2/3. So that's the reason why we have reducing. Now let's address the second concern that we have. Here we had exactly the same fraction. We had 15/10 reducing to 3/2. A lot of you are going to rankle at this, that 3/2 should be made into 1 1/2, because the top should never be more than the bottom. But I assure you of one thing. Fractions are like people. Sometimes the tops are bigger than the bottoms, and sometimes the bottoms are bigger than the tops. Well, maybe I should go into art. Anyway, you can get the idea that fractions, as long as there is no number that is divisible into top and bottom evenly, that's the way that number should sit. If you wish to change that problem from an improper fraction, where the top is bigger, into a mixed fraction, this is the way you do it. But it is reduced, and it is perfectly fine.